In this video, I am going to solve the 25th problem from chapter 17, Waves Part 2. This question has 4 subdivisions. Let's answer one by one. Find the speed of the waves on a violin string of mass 860 milligram and length 22 centimeter if the fundamental frequency is 920 Hz. So you have violin string and its mass is mentioned. So what is the mass of the violin string? The mass of the violin string is 860 milligram. So we have to convert this in terms of kilogram. So first I have to substitute the value for the milli, which is 860 multiplied by 10 power minus 3. So this 10 power minus 3 is for milli, right? And for converting this gram to kilogram, we have to multiply one more 10 power minus 3, right? Because 1 gram, which is equal to 10 power minus 3 kilogram, right? So I have to add these two. So therefore the mass of the violin string is 860 multiply 10 power minus 6 kilogram. And what is the length of the string? The length of the string, they mention 22 centimeter. To convert to meter, which is 22 multiply 10 power minus 2 meter, right? And they mention this, it have the fundamental frequency. So the fundamental frequency value is 920. What is the meaning for fundamental frequency? It has only one loop. N is equal to 1 is nothing but the fundamental frequency. So by using this, we are going to find what should be the speed of the wave on the string. So we know the rule, the speed of the sound V, which is equal to frequency multiplied by lambda. So first of all, I'm going to draw the diagram for the fundamental. So you have a string, violin string, so which is fixed at both ends. So it has the fundamental frequency, right? So which is N is equal to 1. So by that, if you take, this is the L, which is the total length of the wire, the string, L, which is equal to how many lambdas you have here? 2 quarters of lambda, which is L is equal to 2 lambda over 4. So we can cancel this. So therefore L, which is equal to lambda over 2, therefore lambda, which is equal to 2 times of L, right? And once you got the answer for the lambda, we can easily find the answer for the first part, because we know speed, which is equal to frequency multiplied by lambda, right? So what I'm going to do, I'm going to take and substitute the lambda here, and the fundamental frequency is already given here as 920 Hertz. So I'm going to substitute this fundamental frequency here. By that we can get the answer for the first part, right? So therefore V, which is equal to, the fundamental frequency is 920 multiplied by 2 times of L. So therefore 920 multiplied by 2 times of, the length is 22 centimeters. So 22 multiplied by 10 power minus 2. So I'm going to multiply all for getting the answer for the first question. So 920 multiplied by 2 multiplied by 22 point, so 22 multiplied by 10 to the power minus 2, I got 404.8 meter per second. Clear? So this is the answer for the first question. Okay, now we have to go for the second part. What is given in the second part? What is the tension in the string? As we know the rule of the speed of the wave on the string, V equal to square root of T over mu, right? And here the T we are going to find, where mu is the mass per length, mass per unit length. And I'm going to substitute this mu here. By that this equation will become T over M over L, right? And this L will go to the top. By that the above equation will become TL over M, right? And we are going to find the tension. So I have to take square. I have to squaring both the left hand side and the right hand side. By that this becomes V square, and right side becomes TL over M. So I have to rearrange this equation in terms of tension. So therefore tension which is equal to mass multiplied by V square over the length of the string. So we have all the values. The mass of the string is 860 milligram, which is 860 multiplied 10 power minus 6 kilogram, and the speed we found in the first part, which is 404.8, right? 404.8 square over the length of the string is 22 centimeter, which is 22 multiplied by 10 power minus 2. So I have to multiply the top and then I have to divide with the bottom. So let's see what is the value for the tension. The value for the tension, say 860 multiplied by 10 power minus 6 multiplied by 404.8 square over 22 multiplied by 10 to the power of minus 2. I got 640.5 Newton. So this is the answer for the second question, right? Okay. We have to go to the third question. What is the wavelength of the waves? What is the wavelength of the waves on the string? And we already calculated the wavelength here because this string will have the fundamental frequency. By that, we already calculated the wavelength. So better I can calculate the third question here. For wavelength, we already calculated lambda, which is equal to 2L. So therefore, 2 multiplied by 22 multiplied by 10 power minus 2, we got 44 multiplied by 10 power minus 2 meter. Clear? That's it, because we already find the answer, right? So this is the answer for the third part, and we have to go for the fourth part. For the fundamental, what is the wavelength of the sound waves emitted by the string? So now we have to find what should be the sound coming out of the string. So for that we need the speed of the sound in air. So therefore for the part D, I'm going to use the rule V, which is equal to frequency multiplied by lambda, and we are going to find what should be the wavelength emitted by the string. Am I right? Therefore lambda, which is equal to speed over frequency. So for the speed, I have to use the speed of the sound in air because it is emitted from the string. That means the sound wave is coming out of the string. So we need the sound will be passing through the air, right? So we have to substitute 343 for the speed of the sound in air over the fundamental frequency is 920 hertz, right? So I have to divide 343 over 920. I got the answer as 0.3728. So better I can write two digits, 0.373 meter, right? So this is the answer for the last question. So here we have 4 questions and all the questions are related to each other, right? So read and write the rule carefully and substitute the value and find the answer. That's it. Thank you.